LM26484 Power Management Unit by National Semiconductor. Welcome to the training module on National Semiconductor LM26484 Power Management Unit. Today's training outline consists of an LM26484 overview, applications, LDO, and buck regulators operation. The LM26484 is a multifunction configurable power management unit. This device integrates two highly efficient 2-amp step-down DC-to-DC converters and one LDO controller. All regulator output voltages are externally adjustable. The LDO controller is a low-voltage N-channel metal oxide semiconductor voltage regulator. Because the LM26484 is externally configurable and has many voltage options, it is possible to change the feedback network to get a different regulator output voltage. The highly integrated and complete power management solution is specifically designed for core and I/O supply, such as FPGAs, ASICs, and DSPs. The other applications include automotive, set-top boxes, cordless phone base, network routers, and printers. This slide shows a typical application circuit of the LM26484. The detailed explanation is introduced in the next few slides. The LDO is a line regulator which targets analog loads characterized by low noise requirements. The LDO is the best regulator when the difference between input and output low is low, or the efficiency is a secondary concern compared to the output noise, ripple, cost, and solution size. Dropout voltage is the minimum difference between unregulated input voltage and the regulated output voltage, for which the regulator will operate within specifications. The lower dropout voltage is the reason LDO regulators dominate battery-powered applications, since they maximize the utilization of the available input voltage and can operate with higher efficiency. The output voltage of the LDO on the LM26484 is established by the feedback resistor divider R5 and R6 as shown. The LDO is enabled through EN LDO pin, which enables LDO when it's at logic high. The LDO control loop will force the voltage on VFR to be 0.50 volts. Therefore, based on the equation given on the page, we're able to calculate the resistor values. The table shows ideal resistor values to establish LDO voltages from 0.8 volts to 1.5 volts. A feedback capacitor C11 is required for stability. Recommended values can be seen in the table. The output capacitor C10 must meet the requirement for the minimum value of capacitance and also have an ESR value that is within the range of 50 milliohms to 500 milliohms for stability. A 10 microfarad ceramic capacitor is recommended for proper operation. When selecting an N-field effect transistor for the LM26484 controller, it is important for the N-field effect transistor to have a maximum power rating larger than the application will need. The buck regulator is used to downconvert a DC voltage to a lower DC voltage. The LM26484 incorporates two high-efficiency synchronous switching buck regulators, which are 180 degrees out of phase. SW1 and SW2 deliver voltages from a single DC input voltage. Using a voltage mode architecture with synchronous rectification, both bucks have the ability to deliver up to 2 amps depending on the input voltage, output voltage, and the inductor chosen. Both SW1 and SW2 can operate up to 100% duty cycle for low dropout control of the output voltage. In this way, the output voltage will be controlled down to the lowest possible input voltage. There are 3 modes of operation depending on the current required: PWM, PFM, and shutdown. PWM mode handles current loads of approximately 70 milliamps or higher, delivering voltage precision with high efficiency. Lighter output current loads cause the device to automatically switch into PFM for reduced current consumption and longer battery life. The standby operating mode turns off the device, offering the lowest current consumption. When the converter is enabled, soft start is activated. The soft start feature allows the power converter to gradually reach the initial steady operating point, thus reducing startup stress and surges. The 2 LM26484 buck converters have a soft start circuit that limits inrush current during startup or ramps up output voltage over 500 microseconds. The 2 buck regulators can operate at 100% duty cycle for low dropout support of the output voltage. In this way, the output voltage will be controlled down to the lowest possible input voltage. When the device operates near 100% duty cycle, output voltage ripple is approximately 25 millivolts. The buck control loop will force the voltage on VFB to be 0.50 volts. The table shows ideal resistor values to establish buck voltages from 0.8 volts to 3.5 volts. In addition to the resistor feedback capacitors C3, C4, C6, and C8 are also required. There are several design considerations related to the selection of the output inductors and capacitors, including load transient response, stability, efficiency, output ripple voltage, and overcurrent ruggedness. The LM26484 has been optimized for use with nominal values from 0.5 microhenries and 22 microfarads.